Hello everyone. In this video we're going to talk about perfect square trinomials. So we have certain binomial products that have special forms. Now when a binomial is squared, the result is called the perfect squared trinomial, which is here, the perfect square trinomial. Now we can find the square by multiplying the binomial by itself. But however, note that there's a special form that each of these perfect square trinomials takes. Memorizing the form makes squaring binomial much easier and faster. That I might say. But let's look at some of the few trinomials. So let's say we have let's say x plus 5 squared. When we do this, when we square this, what are we going to get? We should get something like x squared plus 10x plus 25. Right. Let's take another one. If you have maybe x minus 3 squared, when we square this, what are we supposed to get? We will get something like x squared minus 6x plus 9. Right. Now, and when you square, let's take the last one, maybe 4x minus 1 squared. This one too should be 16x squared minus 8x plus 1. So with these three examples, you can note that the first term of each trinomial is the square of the first term of the binomial, right? And similarly, the last term of each trinomial is the square of the last term of the binomial. You can note that. So the first term here is the square of this binomial here, and the last term is the square of the last term of the binomial. You can see that, right? So, and the middle term is the product of the two terms, right? So lastly, we can see that the first sign of the trinomial is the same as the sign of the binomial, as you can see there. So what do we mean by that? Now, when a binomial is squared, the result is the first term squared added to the product of the both terms, and the last term squared, right? So what is the meaning of these statements? So let's say we have maybe x plus a squared, right? So with this one, we should get this one, we can also expand it in the form of x plus a multiplying x plus a, right? Now when you do this, you can see that we can multiply x times x, then we get x squared, right? Then the next one is multiplying x times a, then we get ax. The next one, x times a, then we get ax. The last one is a times a, then we get a squared, right? So when we do it, we should get x squared plus 2ax plus a squared. That's what we mean. Now, how do we do this? Now, when given a binomial, square it using the formula for perfect square trinomial. So the first thing that you need to do is to square the first term of the binomial. Then the second thing that you need to do is to go ahead and square the last term of the binomial. Then the third thing that you need to do, for the middle term of the trinomial, just double the perfect of the two terms. And then lastly, just add and simplify, and you are good to go. Let's take an example here. So let's say we have this example, 3x minus 8 all squared. How do we do this? Now, as we said, we have to begin by squaring the first term and the last term. So let's do that. So squaring the first term, so this is our first term is 3x, so 3x squared, right? Then our last term, what is our last term here? So let's say our last term is negative 8, so negative 8 squared, right? Then the next thing that we need to do is for the middle terms of the trinomial, we just double the product of the two terms. So that will be negative 2 3x and 8, then plus is there. You can see that. Now let's just go ahead. The last thing that we need to do is to just add and simplify. So adding them, we should get 9x squared minus 48x plus 64. Very simple to do. Now you can try this on your own. Try this. So just expand maybe 4x minus 1 all squared. Try this and put your answer in the comment section. So now let's talk about another thing. Another thing that we want to discuss is the difference of squares. So the difference of squares is another special product, and it's called the difference of squares, which occurs when we multiply a binomial by another binomial with the same terms. You get that? So the difference of squares is when we multiply a binomial by another binomial with the same terms but opposite sign, right? So let's see what happens when we multiply maybe let me say x plus 1, which is very common, and x minus 1. You see, it is the same term, right? But the different sign, this minus sign and this a plus sign, right? So with this one, when we multiply them, we should get x squared minus x plus x minus 1. And when you simplify and add everything, you should get x squared minus 1, right? So you can see that the middle term drops out, resulting in the difference of squares. So just as we did with the perfect square, let's look at a few examples again. So let's say we have maybe x plus 5 and x minus 5, right? This one you should get x squared minus 25. Another one maybe x plus 11, x minus 11, and this one you should get x squared minus 121, right? And go on. You can give more examples. Now, because the sign changes in the second binomial, the outer and the inner terms cancel out, right? Now you will be left only with the square of the first term minus the square of the last term. Now, another question you have to ask yourself is that, is there any special form for the sum of squares? What should be your answer? You can pause the video and try to think about this question and give your answer and explain it, if you have it or we don't. Now, my answer is no. What is the reason? Now, the difference of square occurs because the opposite sign of the binomial cause the middle terms to disappear. So there are no two binomials that can multiply to equal a sum of squares. So for me, my answer is no, and my reason is the difference of squares occurred because the opposite signs of the binomials causes the middle term to disappear, and so there are no two binomials that we can multiply to equal a sum of squares. I hope you got your answer correct. So let's note this. Now, when a binomial is multiplied by a binomial with the same terms separated by the opposite sign, the result is the square of the first term minus the square of the last term. What do we mean by this? So let's say we have a plus b and a minus b multiplying each other, right? We said we just square the first term of each binomial. So with this one we get a squared, then the last term, right, minus b squared, because when we do it the middle term disappeared. That's the difference of squares. Very simple. Now, how do we do that? So let's say when you are given a binomial which we are supposed to multiply by a binomial with the same terms but the opposite sign, how do you find the difference of that squared? Now the first thing that we need to do is to square the first term, right? You square the first term of the binomials. The second thing, step by step, to do is square the last term of the binomials. Then lastly, you subtract the square of the last term from the square of the first term. Very simple to do. Let's take an example here. So let's say we have 9x plus 4 multiplying 9x minus 4. How do we do this? So as we said, we need to square the first term to get. So what is the first term here? 9x, right? 9x. So let's square the 9x. So 9x squared. And when we square this, we should get 81x squared, right? That's the first term. Now, the second thing we need to do is to square the last term to get what? So, what is our last term here? That is 4, right? So, 4 squared, which is 16, right? And then lastly, what you have to do is to subtract the square of the last term from the square of the first term to find the product, right? So with this one, this is the first term, so 81x squared, and we subtract it. So we are going to subtract the last term from the first term, so that's 81x squared minus 16, right? And we get our answer for that. Very simple to do. Very simple to do. You can also try this on your own. Try this one. So multiply 2x plus 7, then 2x minus 7. Try this and put your answer in the comment section, and I'll see you in my next video. Thank you for watching this video.